Suppose you want to create an ideal operating system where unnecessary packages don't pollute your user space. As a bonus, your shell scripts will also become entirely declarable, so you can send them to your friends or colleagues without worrying about any dependencies. You can accomplish this with Nix packages function called writeShellScriptBin. All it does is create a shell script in your Nix store, makes it executable, and returns its path. So how can we NixOS users incorporate it into our workflow? It's very simple. Let's begin by creating a file called myawesomescript.nix. All it will contain is a function that takes packages as an input and returns an output from pkgs.writeShellScriptBin. WriteShellScriptBin itself takes two parameters, the desired binary name and the content of the script. It will include the shebang at the top automatically, so you don't have to specify it. Notice that to make a multi-line string in Nix language, we are using two double single quotes. So let's say you want to make a simple script that echoes hello world, then pipes it into cowsay to draw a funny ASCII image, and then pipes it into lolcat to make it colorful. Our standard Unixy way of doing it would look something like this. But we cannot assume that the person running this script has cowsay and lolcat installed. We also do not want people who we share this script with to clutter their user space by adding all of the dependencies to their configuration. So let's move our script into the .nix file and address these issues. We will add this special structure before each binary. The pkgs.cowsay variable, when interpolated into a string with a $sign, will turn into a Nix store path once our script is compiled. So each of these variables will be replaced with something similar to this. But how can I determine if a package cowsay actually contains cowsay binary? It may be obvious in this case, but the package name may not necessarily match the name of the binary. For example, if I want to install vlcopy command, I won't find a package with that exact name, and instead will need to take it from a different package called vlclipboard. There are many ways to find out which packages contain specific binaries, but here are two easy methods that I recommend. If you are already an experienced Linux user, you may already know the package names and their contents from other distributions. In this case, you can use this nix build command, which builds your desired package in your Nix store and prints its path. It's going to be removed once you garbage collect your system, so don't worry about it taking some space. Then just cd into this directory and browse it to make sure that your required binary is there. If you are unsure where your binary is located or don't want to wait for packages to build, you can use the Nix-index package to index the entire Nix packages, allowing you to locate any files stored within it. I also recommend using Nix-index database, which is a wrapper for Nix-index that is updated weekly. With it, you don't have to index Nix packages locally, saving you a ton of time. To add Nix-index database to your NixOS configuration, use the flag that provides it. You can find a link to it in the description. After rebuilding your system, if you try to run nix-locate vlcopy, you will see where vlcopy is located, which is of course in vlclipboard package. So now let's finally return to our script. To make use of it, we can put it in NixOS configuration, dev shell, or its own derivation. Let's go over the first one, because all of you probably already have your NixOS config ready. All we have to do is import the Nix file relatively to our configuration.nix and make it inherit packages because we defined it as a required parameter. You can either add your import directly into packages or define it as a variable at the top using the let and in syntax and then reference it in packages. After rebuilding your system, you'll notice that we can now run our script even though neither cowsay nor lolcat is actually present in our user's environment. To fully understand what Nix did here, let's check the content of the script. The which command returns you the location of the executable, and bat is just a colored cat command. As you can see, Nix indeed added the shebang at the top and also replaced our package variables with the complete path linked to the Nix store. You can import these shell scripts to any Nix expression that requires packages. For example, to spice up your dev shells with fancy run or test scripts. But the best thing is, concepts that you have learned or reminded yourself in this video will help you when we eventually come to derivations. They are a way to describe the process of building a Nix package, and understanding them will grant you unlimited power. But now I'm already getting ahead of myself. So we have reached 1000 subscribers, which means that I am now obliged to create a Discord server. The link to it is in the description. Make sure to join if you want to share and receive some nerd knowledge or vote for future video ideas. I'm going to be setting it up right after this video goes public, so come say hi if you want. And what about the channel? Oof, 1k subs in less than a month. That's pretty good, I think. I didn't expect to reach it even in 5 months, but here we are. Now, how about this? The first person who counts how many times I've said Nix in this video, writes it in general chat on Discord, and gets a colored name on the server. I think it will be quite fun, and thank you so much for watching, sharing and subscribing. Really hope you enjoyed this video, and see you in the next one.